Dropping out of light speed, a fleet of rebel spaceships is greeted by a frenzy of laser blasts, illuminating the sector with brilliant bursts of light. Science fiction has shown us scenes like this for decades, but the lasers in our daily lives seem far less dazzling and destructive. Laser eye surgery can cut tissue, and laser cutters can shape wood or plastic, but neither seems strong enough to pierce a spaceship. And laser pointers are more likely to annoy a cat than an evil empire. So could sci-fi laser weaponry ever exist? And how do lasers even work in the first place? Lasers are devices that produce laser beams, which are ultimately just a form of light. But these beams have special properties. For example, the ordinary light from this incandescent bulb is composed of a rainbow of colors, each of a different wavelength, and the particles that make up the light, called photons, randomly emanate outward in all directions. Laser beams, on the other hand, are much more organized. They're generated through a process called stimulated emission, which is part of the acronym that gave this tech its name. Every laser houses a few photons, and when the device is turned on, it begins exciting a large number of electrons. Stimulated emission begins when these particles collide, causing each electron to emit a second synchronized photon of the same color. This photon then strikes other excited electrons, which in turn emit more and more of the same type of photon. Eventually, this chain reaction generates an organized stream of light particles known as a laser beam. Stimulated emission imbues these beams with two unique properties. They're monochromatic, meaning their light is composed of a single color, and they're coherent, meaning their light waves are all synchronized and travel in the same direction. These two traits give laser beams all kinds of special abilities. Whereas the light from a standard bulb spreads out to fill a room, coherent laser beams stay narrow, allowing some to travel over distances as large as thousands of kilometers. Coherence also makes laser beams great for carrying information. Since their light waves are perfectly synchronized, it's easy to detect any changes in the beam. For example, when you shine laser light on a barcode, the scanner can precisely measure the reflected light and convert the pattern of black and white into data. Being monochromatic and coherent are also what gives laser beams their destructive potential. Whereas ordinary light distributes its energy across a large physical space and a spectrum of colors, laser light concentrates its energy into a narrow single-color beam. However, there are limits to how powerful these beams can get. First, stimulated emission is incredibly fragile. As lasers increase in power, the more internal heat they generate. Heat de-excites electrons, rendering them unable to participate in the chain reaction that produces laser light. So when there's too much excess heat, the mechanism gets disrupted and the laser stops working. Furthermore, while laser beams can travel huge distances, doing so causes the beams to get scattered and absorbed by air molecules and other particles, weakening the light until it disappears entirely. For all these reasons, blasters and laser cannons will likely remain in the realm of science fiction. However, this doesn't mean lasers can't hurt us. So while lasers can take down a starship, they still need to be used with care and caution.